I'm working my laptop. It's recording. Hello, class. Say hello.
Hello.
Say hello, Erin. Say hello, Erin. Yeah, Erin's doing her test, so I said, "Well, I'm gonna record this." What? Karen? No, you have to sit here. Oh, wait, you've seen this stuff before. Yeah, you can go do it. All right. Today we're going to balance half equations. I don't know if this featured in the other classes' organic chemistry test, but if it did, I'm pretty impressed because it's, to me, quite a high-level concept. I'm going to show you two reactions. Now, dichromate. What will dichromate do to a primary alcohol? It'll change colour, won't it? It tells you you've got a primary alcohol. So let's use Andrew's favourite primary alcohol. Oh, can you put this pen in the bin? It's rubbish. Alright. What are we looking at there? Ethanol.
What's the title?
What?
What's the title of this?
RedOx Half-equations. Elephant. Snake. Red.
Should we actually write that?
Well, Jack wants a title. There you go. There's your title, Jack. RedOx Half-equations, elephant, snake, red octopus, sponge. That's your title.
When you say that again, can I take that on video?
What'd you learn?
Yeah, it's already on video, man. Okay? Ethanol. Ethanol is a primary alcohol because it's attached to one carbon and two other hydrogens. Now, when exposed to dichromate, it turns bluey-green. Now, it is the dichromate that does that, not the alcohol itself that turns blue. Because chromium, just about any of these transitional elements here, the way they bond, if you start changing their oxidation numbers, it changes the way they interact with visible light, so they look really pretty, which is why, go away, fly. There's all these students in here, why do you have to be near me? Go! Yeah, Alex, yeah, take the fly.
Yeah, no.
It's back on you.
Did it? Yeah, it's in the bag. No, keep it. Okay. Oxidation states, transition metals, many available, many different colours, many different ways they interact with visible light, which is why you get all these pretty gems and stuff because they have white crap in it. So this here doesn't actually turn blue-green. What this will do will be, it will oxidise in the presence of K2Cr2O7 aqueous, and it also must have an acid available to become first. Oh, it might be that. Might be this. What's that? No.
No.
Johanna. No. Okay, 3. What is it? I am going to smash my head on the wall in a second. It's an aldehyde. Thank you, Talia. At least someone knows what's going on. It's probably because I didn't teach it. This is ethanol. Remember, a double bond O is either an aldehyde or a ketone, and when it's a terminal group, it's an aldehyde. So this is ethanol. But there's another step. Again, oxidise.
Ethanol.
It will oxidise to this. No. Double bond O, bond OH. Okay, what's that?
Ethanoic acid.
Thank you, Kieran. Trust you to know what the acid is. Okay. Let's say we had a secondary alcohol. Give me an example of a secondary alcohol. Propanol, good answer. C, bond C, bond C, bond OH. 1, 2, 3, 4, 1, 2, 3. Carbon there. Better. That's a secondary alcohol. Now when you have that, with your H plus K2Cr2O7 certified potassium dichromate, you're going to get, through oxidation, and it's just a one-step process for this. There's a two steps here. There's one step and two steps going from the alcohol to the aldehyde and to the acid. But in here, you get a secondary alcohol. It'll oxidize simply to a ketone. Which in this case here is methane, propane, toluene. Would you need to say propane, toluene? Or could you just say propanone?
We can say propane.
Why would saying the two be
Because if you
unnecessary?
chucked it on the end, it'd have to be a
Propanol.
Yeah.
propanol.
Propanaldehyde. Propanol is this amazing chemical. I used to bring it out in the class because it's one of the components of rotting bodies and meat and stuff. So when all the students were stuffing around, I'd open up the propanol and waft it everywhere, and then the whole room would just reek like rotting meat. It's just a lot of fun.
Lovely.
Yeah, well, we use it for
Do you know the definition of sadism?
sadism. I don't know, what is it?
It's
You're
like,
on video.
it's like it's like purposefully doing like cruel, harmful things.
You know, I'm not smiling.
This is not sadism.
No, I'm not
This is
saying
chemistryism.
I'm not saying-
And I wafted it. I didn't stick it under their noses. Come on. Alright. So you're going to go from a secondary alcohol to a ketone. Now, this two-step process here, I'll just leave that there for a moment. Let's do this one because it involves one step, therefore it involves less work for me. So you need to be able to get this, especially for you, Alex, and turn that into both a molecular formula and a, what do they call it? Molecular mass. But in this case here, we're just interested in the formula. So we get C3, 1, 2, 3, 4, 5, 6, 7, H, 7, O, H. That's what that is. Right? So, and then we add. Now, what we're concerned with here is not so much that or that. This is a catalyst. Now, what do we know about catalysts? Yep, speeds up the reaction, orientates the molecules in the correct way, which increases the number of.
Rectification.
Lovely, I love these terms, they're all the points terms. Potassium. What's potassium going to do?
Spectator ion.
Yeah, well done, Sri. Spectator ion. There's a bloke in my chem class at Lachlan, his nickname used to be Spectator ion because he never did anything. The students named him that, and I didn't oppose it. Very nerdy nickname, I thought it was good. He was an A-level student, he didn't have to do anything to get an A, so he was a Spectator ion. So we're concerned here not with the hydrogen or the potassium, but rather this bit here, which is the dichromate ion, Cr2O7 2 minus. So you're mixing the alcohol with the dichromate, Cr2O7 2 minus. Now, mind you, both of these are aqueous, and in the middle of this you're actually adding H2SO4 aqueous. What's that, Tali? No! This sulfuric, thank you. Good. You could work it with hydrochloric too, but sulfuric's more powerful. Now, when we're talking equations, you've got here like this whole equation and you'd have your products, but we're in redox now where we deal in half equations, so you're only looking at one product at a time. Now I've told you that this will become a ketone, so this is your secondary alcohol and we need to work this one out, which is going to be C3H, 6H, 6O. So that's the formula for the aldehyde. So you've got two half equations occurring here. The other is the dichromate half equation. And if there's an equation that you need to know, it is this. And you have two options. You can either understand it, well, three really. You can do nothing. You can be a spectator on it. Or you can understand it, or you can just simply memorize it and spew it out onto paper when it suits. the understanding will come in time if you choose that method too. So it's a possible look, cover, write, check. So I'm going to tuck the alcohol reaction half equation up here for the moment, and I'll come back to that. C3H7OH becomes C3H6O. Now you'll see, you know, here we've got 7, 8 hydrogens, but over here you've only got 6. So there have been changes made to the way it chemically is. I mean, clearly it's gone from being a secondary alcohol to a ketone. So there are structural changes occurring there. Now, let's progress the dichromate stuff. And you'll want to make sure that your notes on the dichromate ion are nice and clear and very easy to follow and very easy to find, because you will want to refer back to this. CR2O7 to minus, and you always leave yourself plenty of space, Cr. Now, if you look at chromium on your periodic table, what's the charge in the chromium ion? Yell out someone when you get a chance. 3 plus. Metals are always positive for the most part, unless of course, for the most part they'll always be positive. So this here, I mean, there's stuff here and there's stuff here, but they don't add up. Now there is a set of rules that are associated with studying this. Has someone got a chem book here? I'm going to borrow yours. I think it's page 95. Let's have a look here. 3. Oh, look at all those questions that aren't done, Harley.
Yeah.
Yeah.
Oh.
94, please. Page 94. And you will see two methods for doing half equations. The bottom one, oxidation number method, I don't follow. I follow the ion electron method. Now, the first step is write down the reactant and the product in a skeleton equation, including oxidation numbers to decide the element being oxidized or reduced. Now in this case here, that's the skeleton equation, and we've got to look at this. So in this case here, what's the oxidation number for the chromium? 3 plus. And in this case here, what is it? Well, you've got 7 oxygens. Is this hydrogen peroxide? No. So the exception's not in force. 7 times 2 is negative 14, but we want to bring it to negative 12 because it's a minus 2 polyatomic ion. So to get negative 14 to negative 12, we must have plus, well, it's going to be plus 12 overall, but there's 2 chromiums, so each chromium is going to become plus 6. So you've gone from plus 6 to plus 3. Now what's occurred here?
It's gained electron.
Yeah, it's reduced, hasn't it? Oil rig. Oxidation is loss, reduction is gain. So it's gone from more positive to less positive. So it's gained electrons. It has reduced. Hence why they call this an oxidizing agent, because it causes the other thing to oxidize. For when there is a reduction, the other thing must oxidize. This is an oxidizing agent. And that's why when you get it in the box, it's got oxidizer in it, just like the pool chlorine and all that sort of stuff. Alright, we fulfilled that step. Can I rub it out? That's what. What's the next step, Harley? Sorry, I don't remember them word for word. I know they're doing it in my head.
Balance the number of atoms.
Oh, this?
Yeah.
Oxidized or reduced.
There.
So, balance the number of atoms being oxidized or reduced. That has to do not so much with the oxygens or the hydrogens, but with the chromium. So you've got 2 of them there. How many do we need over here? 2. Put number 2 there. Okay, we've done the next step. Now what's next?
Determine the change in oxidation number and balance this with electrons. Add the electrons to the side with the highest positive oxidation.
No. Balance the number of atoms of oxygen by adding water to the side deficient in oxygen.
Yeah, where'd you read that, Jack? That's like
What's the
step.
other
That was the oxidation number.
No, yeah, we're doing the top one. Okay, so you balance the side deficient in oxygen with waters. Now, left to right, which one has a deficiency of oxygen?
Right.
Right, the right hand side does. So, if we've got 7 oxygens here, how many waters am I going to need to balance that out? Yeah, because each one has 1 oxygen. H2O and there are 7 of them. Right, next step.
Balance the number of atoms of hydrogen by adding hydrogen ions to the side deficient in hydrogen.
Okay, well, over here we've got how much hydrogen?
0.
0. And over there?
40.
There are, good. Don't fall for the trap of thinking there's only 7 of them. There's 2 lots per every water. So, now this is a big point here. You add hydrogen ions, protons, not hydrogen itself. H plus. But we're going to need a few of them. That's why I should leave some space. We need 14 H plus. Okay. Now this is why it's acidified potassium dichromate, because you need these acids available to facilitate the reaction. If that's not available, it will not work. Next step, Harley.
Balance the charge by adding electrons to the side with the highest total positive charge.
Great. There's a nice trap available here in regards to that. Let's look at the overall charge of this side. What's the charge on a water molecule? 0. There's no charge on there, so it's 0. What's the charge here? There's 2 of them. Yeah, overall it's plus 6, because you've got 2 lots of plus 3 ions there. So, what have we got over here?
-2.
Alright, we've got 14 and 14 pluses and 2 minuses, giving you overall plus 12. So how do you go from plus 12 to plus 6?
You lose 6 electrons.
Yeah, you need 6 electrons to stick onto those to go from plus 12 to plus 6. So it's plus 6 E minus. Next step.
Check that all atoms and charges balance.
Check that all atoms and charges balance. 2 chromiums, 7 oxygens, 7 oxygens, 14 hydrogens, 14 protons. Good. Alright, overall here, 2 times 3 plus is plus 6. Over here, 2 minus and 14 plus is 12 plus. And then to go from 12 plus to 6 plus, we add 6 electrons. We are balanced electrically.
And then write in physical states.
Oh, okay. Right. Aqueous. You just leave the electrons, they're not really aqueous. This will be aqueous, and this will be liquid, of course, because we're going to have aqueous water, there's no such thing. Oh, go away, fly! This is a balanced redox reaction half equation. Now, is this oxidation or reduction?
Reduction.
Okay, so I've got half and half.
Oh no, yeah.
Yeah, that's right. You look at what's on the left and what's on the right. If the electrons are being added, then it is gaining the electrons, and based on oil rig, reduction is gain. So this has reduced. This is a reduction reaction, just by simply looking at where the electrons are. Now we've got to do the other reaction too. This baby here. So let's follow that through. C3H7OH becomes C3H6O. Alright, step 1. Step 1, Harley.
I don't remember. Write down the reactants and products and skeleton equation.
Yep, done.
Balance the number of atoms of the element being oxidized or reduced.
Okay, 3 carbons, 3 carbons. We're good. I mean, clearly it's the carbon with the double bond O that's getting the attention. So, I've balanced that. That step's done.
Balance the number of atoms of oxygen by adding water to the side deficient in oxygen.
Okay, which side's deficient in oxygen? Neither. So what do you think you do with that step? Skip.
Get rid of it.
Alright, next step.
Alright, balance the number of atoms of hydrogen by adding hydrogen ions to the side deficient in hydrogen.
Okay. How many hydrogens on this side?
8.
8. And how many on that side?
6.
Right, so what do I do?
Yeah.
2 protons to this side, 2 H plus. Very good. Next step.
Balance the charge by adding electrons to the side with the highest total positive charge.
Okay, what's the charge on the left? 0. What's the charge on the right?
Plus 2.
Alright, how do you go from 2 plus to 0?
Yeah, 2 electrons.
Plus 2E minus.
That is oxidation.
And then you check.
That is oxidation because it's losing electrons. And this is an oxidizing agent, so the dichromate causes the primary alcohol, or in this case the secondary alcohol, to oxidize.
So how do we know that it's the carbon that we're focusing on? Or just
Well,
any...
you don't focus on the hydrogens or the oxygens because they're all added in every
So
step.
in any situation, we just ignore the hydrogens and the oxygens and we focus on the other element?
Yes,
Yeah.
Very
essentially speaking. Now, the thing is, in redox equations, the electrons must balance to be able to get those half equations and put them together for a whole. But they don't do that because you've got 6 on this side and you've got 2 on this side. Does anyone see where this is going? How do you balance 6 and 2? Well, in this case here, you simply get this, brackets around the outside, and you times it by 3. Now it will balance. So for every dichromate is actually able to oxidize 3 primary alcohols in the process because it can pump. It's going to strip 6 electrons, and it will do that from 3 of these. So it's actually a several-step, quite a complex process, but we don't go through the minutiae of those steps. We simply smash these half equations together. Now, if I times that by 3, what am I going to get? Well, you do everything by 3. 3C3H7OH becomes 3C3H6O plus 6H plus 6E minus. Now that, because you've got 6E minus on the right, will balance the 6E minus on the left. Those equations are ready to be put together as a whole. And to do that, I'm going to need some whiteboard space. So what I'll do is I'll just rub out these oxidation numbers up here. And I've already known that this is the equation we're going through, so that gives me some space here. And I'll put a dotted line to delineate the section of the whiteboard that relates to the latest part of the lesson. And I'm going to get these two here, this reaction and this reaction, and it's time to put them together. So you get your half equations and you make a whole. So we start CO2 O7 2 minus plus 14H plus 6E minus, and then you add this because you got to do everything on the left. 3C3H7OH. So that's everything on the left hand side covered there is going to make 2Cr3 plus 7H2O plus 3C3H6O plus 6H plus 6E minus. Now that is a combined full redox equation involving both half equations. But we're still not done. Go away, fly! I don't know what it's landed on, but it keeps landing on my coffee, and whatever goes into me, that's gross. What do we got on both sides of the equation that are the same?
6 electrons.
Yes, well that's the first thing that can go. Where there's the same chemical species, you can actually ditch them from the equation itself, because it's like dividing both sides by the same number. It's the chemical equivalent of that. You've got 6 electrons here and 6 electrons here, so you can actually cancel them out. Now what else is the same on both sides?
Protons.
You've got protons on both sides. So you've got 14 here and 6 here. Now which one's higher, 14 or 6?
14.
Right, so we'll wipe out the 6 and the 14 will change to 8. Because 8, 9, 10, 11, 12, 13, 14. So covers it off. Now is there anything else I can take out? No. So the final balanced and simplified redox equation is going to be Cr2O7 2 minus aqueous plus 8 H plus aqueous plus 3C3H7OH. Aqueous makes 2Cr3 plus aqueous plus 7H2O liquid plus 3C3H6O aqueous. It's a lot, isn't it? That's why I recorded it. This will be one of the most important moments in your chemistry education, especially if you go into stage 2. It will be in your exam. I will put dichromate or permanganate in there, and it will occur over and over and over in stage 2. If you're able to handle this, that's as hard as it gets.
What is
In our exam, will we just have to write the final equation, or would you have to show the steps
No.
in between?
Have to show the steps in between. So I've got a few, like, there's practice problems and all this sort of stuff. And that is a redox equation. So you can do the same thing, but with this and that. You can actually go ahead and get the chemical formula for that, and for that. And each of these are going to be oxidized to an ethanol, oxidized to ethanoic acid. And the dichromate's going to do exactly the same reaction every time. So, you know how I said you can understand it? Well, you can also just simply remember that equation here, this one here, without actually remembering any of the steps. If you just spit that out and make the electrons balance, then that's the other way around it. My preference is that you remember it. So I think at this stage, I will leave it there for redox half-equations, elephant, snake, red octopus, sponge. And we should probably take a look at what's available in your book. Book. Write half-equations for the following oxidizers. Right half, yeah, look at this. There's so many of them. So why don't you look at pages 95, 96 and 97 with answers in the back, and if there are any questions, I am employed to educate you. Please ask. I already told you. Oh, yes. Yeah. How many photocopies do we need?
what pages again, sorry?
95, 96 and 97. 1, 2, 3 photocopies.
Oh no. No, I got
4 photocopies. Right. I'll borrow this. Thanks, Alright. I hope you enjoyed that, Aaron. Yay.